Introduction to face contact modeling. If there is a contact that can separate each other, you have to use face-to-face contact. Here I have three different parts. I will push on this part, and then this should be just on this point there, on this edge. So you have a deflection in this style. I just started a new FEM and sim. Here I looked at the element iterative solvers active. I take at the output requests in case control this contact results active, and in the bulk data I put the parameters here in AB, this payload -1 parameter. Then at least you see what's happening if there is also a great separation or a great movement. It should be okay, everything in there. Now I go directly to the sim file. In the sim file you find here simulation object surface to surface contact. You choose this surface contact. You let find the system yourself, all contacts, and there this friction coefficient should be on 1. So put it on a friction coefficient 1. Okay, and you see he made everything himself. He's looking from contact from this body to this body, and that's remarked with this face to face contact. Perhaps better visible in this. You see which two faces are in contact, in which direction he is looking for contact. So that's the second, and the third is over there. Okay. I return to FEM. In the FEM I make a tetrahedral mesh. In the tetrahedral mesh I make this outer size body. Per body I look at the minimum 2 elements and I say okay. He makes this for mesh. I'm giving the material, everything should be steel. Okay, everything should be okay in the FEM file. Go back to the sim, define the load case. I put the force of 1 ton, 10,000 Newton in YZ direction here, and I just fix it here. Okay. When I have that, I let's solve the problem. I use all my kernels. I have 8-core machine, and now I start the analysis. You see there's a force loop acting on. You can change to convergence, and you see here contact convergence. This contact convergence should go down near 0. So that's happening in here, and after at the 1820 contact convergence is stopping. So I look on the file, there is no error. I just go on and look what's happening in here, and it's quite bizarre. If you look what's happening here, there is a sliding. So because it's just on this edge and this mu is too slow and it has a mesh that's not really symmetrical, it starts to move. Be careful with this size of scale of deformations. That's not really good looking, so I go back here and say absolute one-to-one deformation. Okay, and if I look at the film now, you see it's making a little flexions. It's a little more less than 6 millimeters, but you see the sliding here. What's also okay, that's the stress. We have typical here flexion, large stress, and you can look at the contact pressure levels, so you see what's happening in this contact pressure level, and you see here, or we can see it's a lot of pressure on the side of these cubes. That's the reality, but convergence is really bad because we have too large elements. So that's all I wanted to show you, how to make a face-to-face contact. And you have to do that in the sim file surface to surface contact. Think about that you have to put me on one. I put geometry in the Moodle, and in the Moodle you find the second solution where I used that knowledge that I have to stop it to slide with a geometrical constraint. Look at this example in the Moodle, and you find some other nice examples in the Moodle for this contact to contact surface to surface contact. Think about it, the time for analyzing is really quite long. That's all with this face-to-face contact.